On this one. This one, not the test, on the assignment. And guess what, you guys? So I thought this was ridiculous because whenever you use a document camera, it's like right in front of your face, but my document camera has a remote, and the zoom on the remote works better than the zoom on the document camera itself. So now if you see the remote in my hand, it's not because I'm lazy. It's because there's something about the document camera where the zoom button is messed up on the document camera, but it is not messed up on the remote. So look, did you guys see how easily I zoomed? Did you see that? Have you noticed how much I struggle bus to zoom? It's not that I am bad at zooming. I know how to hit the zoom button. It's that the zoom button is bad. It's bad on the document camera. It's not bad on here. Anyway, I was very excited when I figured that out this morning. So now I can zoom for you. You're welcome. You're welcome, everyone who's been squinty. Yeah. I aim to please. All right. This is gonna be good because I do not have a pencil up here. I don't have a pencil. Oh, that's right. I got some pencils right over here. Oh, there's a pencil on the floor. That's convenient. Okay. So let me just focus a little bit. Ooh, sharp. All right, there we go. Oh, pencil just not in my line of vision. Okay, so the first part of number 9, not too bad. We just have an absolute value graph. So the points for absolute value, we got -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. This was not the hard part of the problem, but I'm just going to be thorough and I'm going to do it anyway. So the transformation for this part was just reflect over the x-axis. So we're just going to take all those points and make the y-coordinate negative. Were you guys happy when you got that text message that said we have a quiz on Monday? You guys aren't getting your remind text messages. Oh, you were like, you saw the text and you were like, oh yeah, homework. You don't even look at it, you just go, I have homework. Yeah. I said the homework and then I said, by the way, quiz coming up on Monday, just a heads up. So now you know. Okay, so here's our absolute value graph. What number should I circle? -3. Should I fill in my circle or not fill in my circle? Not fill it in. And then what part should I keep? To the left. Okay, Beyonce. No? Nobody? Trying to work. All right. So there's my graph that I'm keeping. Now, the second part they wrote, and they just put it out of order, and they put it without parentheses, and they tried to make it as uncomfortable as possible for you. So 4 minus x squared is really the same thing as -x squared plus 4, just written backwards, which is really the same thing as -x plus 0 squared plus 4. So they wrote it weird, but that's what it actually represents. So the transformations are that it has been reflected over the x-axis and it has been shifted up 4. So if we get our points, we've got -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. The only reason that I have these points memorized is because I've taught the class multiple times and I've written them down so many times. So if you want to memorize them, you don't want to have to calculate them in the future, the best thing to do is to write them down every time you do the problem, or to make yourself flashcards if you want to memorize them. That's my recommendation to you, because if you write them down every time, you will memorize them without trying, which is what I have done. Okay, so reflect over the x-axis. We're going to take those y-coordinates, make them negative. And then we're going to take all the y coordinates and move them up 4, shift it up 4. So negative 2, 0, negative 1, 3, 0, 4, 1, 3, 2, 0. Now, if we look at this, our parabola is, we only have the points from negative 2 to 2, right? And basically right here, I can see that I need like one more point so that I can see what's happening at negative 3, because that's the part of the graph that this goes to. So if I go up here and just do one more point so that I can see what it should be and do all the transformations, if I plug in negative 3 to the parent graph is y equals x squared. If I take negative 3 and plug it in for x, what do I get? 9. So that point would be negative 3, 9. If I do the reflection over the x-axis, what does that point become? Negative 3, negative 9. And then if I take that point and I shift it up 4, what does it become? Negative 3, negative 5. Okay. Negative 3, negative 5. It's right there. Negative 5. Thank you. Okay. So, yeah.
I understand why you did that, but I don't understand where you got like the x squared. Is that like our
It's the parent graph. Okay. Because look up here, the little squared.
Yeah.
So the parent graph is the equation with no transformations.
Okay.
Yeah. So I just knew, I got all the normal points, but I knew that with the normal points, I didn't have enough to draw what I needed to draw. I knew that I needed to go at least to negative 3. Okay, so now I've got more of the graph. Okay, so I went ahead and I sketched more than enough at this point. I knew I needed to at least go to negative 3. That's why I did that extra point in there. So now I'm going to go ahead and draw my circle at negative 3, and I'm filling it in. And then what part of the graph am I keeping? Everything to the right, which is basically everything that I drew. Just going to erase this because it doesn't look very nice. Okay, and then I'm going to erase this because it's to the left. Okay. All right. And then the only reason these two are touching is because I drew my hole really big. Not because those two graphs actually touch, but I drew the hole, like I drew a big circle there. Any questions about number 9? I think number 10 was probably the hardest question. I think number 9 was probably the second most difficult. We did number 10 in class, yeah. I think number 9 was probably the second most difficult. We did not do 12. Okay. So today we are going to switch over. We're going to start working on how to find characteristics. You are going to need a calculator today. So what I need for you to do is take the assignments from yesterday, the 2 sheets, take your tests, put them all in the pile. I'm going to come around and pick up the piles. And then as we do that, I need you to come trade me something for a calculator if you do not have a calculator of your own. Alrighty. So, on our notes that we are finishing up, example 2. You guys ready? Are you ready? Okay. Do you guys want to evaluate the piecewise function in your head, or do you want to practice plugging it in on the calculator and use the table in the calculator to evaluate? What do you guys think? Okay. So let's practice plugging it in on our calculators. We're going to hit y equals. And then do you guys remember from the video how we type this in? Yes. Okay. Okay, so we'll have to work on that today. See what we can do to fix that. Okay, so we got x plus 4 parentheses squared. And then how do we do this part with the domain? We switch from mathematics into computer programming. Hell, that's not even a calculator. Hit the division symbol. Yep. We're not actually dividing, though. We're thinking computer programming. And then what do I do now? So before I put the x, I'm going to put a parenthesis. And then now I need to hit the x button, and I need to type x is less than -3. And where do I get the less than sign? Second math. That's where the test is. And so now we're going to go down to less than. It's important that you do less than, not less than or equal to. So less than -3. Okay? All right. Now let's type the next one. -x minus 3. So when you type in the -x, you're going to be using this minus, -x. But when you type the -3, you have to use this minus. So -x minus 3. -x minus 3. And when you type it, the negative in front of the x looks very short. The minus in front of the 3 looks long. -x minus 3. You can leave it like that. And then type the divide. Again, we're not dividing. We are showing the calculator that we're switching over to doing the limited domain for that piece of the piecewise function. And we're going to put parentheses again. And we're going to do x is greater than or equal to -3. So we can put the x. And then how do I get back to where the greater than or equal to symbol is? Second math. Greater than or equal to -3. Okay. Go ahead and hit the window button real quick. Just make sure that your window's normal, -10, 10, 1, -10, 10. That way it'll look pretty similar to this. This graph is -8 to 8, so it's going to look a little bit smaller than this graph, but it'll be about the same. Your calculator doesn't show the holes, but it will look approximately the same. Okay, you guys see how it looks similar? Okay. All right. So we can use the calculator 2 ways, okay? Are we good? Go ahead and bring it over. Let's see what your domain did. It has to do with I don't know why it did that. I don't see any mistake in how you typed it. Did you watch the video last night on how to type in piecewise on your particular calculator? Because your calculator does.
Was there a specific video?
No, it was the color ones can do piecewise. Well, it was in the video last night. There was a point where I said, if you don't have this calculator, you can stop watching, and then people with color were supposed to keep watching. I think it might just be because your calculator is more advanced, so your calculator doesn't do it this way. I honestly don't remember because I don't have a color calculator, so after I made the video on that, I promptly forgot how to do it because I don't have those calculators. So, let's check. Actually, go ahead and do second graph real quick and look and see what your table looks like. Does it say error like this? Joseph, does yours? Uh-huh. That's so weird. So, like, the y1 didn't graph correctly, but wait, does yours say x less than 3 or x less than -3? Did you do 3 or -3? Go back to your y equals. For both?
No,
First one, fix it to -3. That's what you did. All right. So if we look at the table, we got 2 options. We can look at the table to figure out where we can plug our numbers in and what our outputs are going to be. All right, so see how the error switches? It shows you which one, like where you can get your outputs from. So the table can give us some information there. The other thing we should be able to do is hit second trace, number 1, and have the calculator plug in the numbers for us. So if we do option number 1, then the calculator says, yes, what x would you like to plug in? And I'll say, I would like to plug in -6. And it will just plug in -6 to the piece that it should be plugging into. And we have no idea which piece it's using because it's doing it for us. Does that make sense? If we want to know which piece it's using, we got to look at the table. Okay, so if we're plugging in -6, which piece is it using? The first one. Okay, so -6 is a number that is smaller than -3. And so you use the first piece. And when you plug in -6, your output is 4. All right, if you want to plug in -3, -3 is where the pieces switch, right? If you want to plug in -3, do you use the first piece or the second piece? You use the second one because the second one is where the equal sign is. The second one is where the equal sign is, but if we use our calculator, you can see the -3, the first one has an error. The second one is where it allows you to plug it in. Okay, so the first one says less than -3, you can't plug it in there. The second one says greater than or equal to -3, that's where you're actually allowed to plug it in. Okay, the answer there is 0. All right, if I want to plug in 0, which one can I plug it into? The second one. 0 is a number that is greater than -3. 0 is bigger than a negative number, so it gets plugged into the second one. If I plug in 0, I get -3 as an answer. Because I get -0 minus 3, -3. And then if I plug in 10, 10 is going to be plugged into the second piece. If I plug in 10, what am I going to get? -13. All right. Now, if you are struggling with your domain, the table can actually kind of help you figure out what x's are allowed to be plugged in. The x's that are not allowed to be plugged in are the ones that say error for both. Does that make sense? Error for both. You can't plug it in. So the number that we are most concerned about is -3 because that's where the funkiness happens. Do you guys see that? The funkiness happens at -3. I'm not worried about any of these numbers. You guys see that? I'm not worried about any of those. I can see that all of those x values are being used. I'm not worried about any of these numbers either. I can see that all these x values are being used. I can see an arrow going forever to the left. I can see an arrow going forever to the right. So I'm not worried about those x values. The only x value that I'm worried about is -3. Does that make sense? I can look at my table and I can see that at x equals -3, there is not an error message for both. There is only an error message for one, but over here, x equals -3 has an output of 0. That means that x equals -3 is being used. That means it's not missing. So our domain is from -infinity to +infinity. This graph goes left forever, and it goes right forever. No missing numbers. Does that make sense how I figured that out? So I wasn't worried about the parts of the graph that were not funky. Those parts were good. They were pretty normal. I was worried about the parts of the graph where the weirdness was happening. Does that make sense? Okay, so the only part of the graph that I was worried about was right here. Everything else looked pretty normal. Okay, now when I think about range, I'm looking at up and down. Is there anything abnormal here? Do you see any y values that look like they're missing there? Nope, the graph goes down forever. Okay, do you see any y values that look like they're missing up here? Nope, the graph goes up forever. So the only thing I'm really worried about is that middle part. So we just have to make sure that there's no y values in the middle that are missing, okay? So we get right up here. The first thing I see that's kind of weird is that there's 2 places where we have a y value of 0, so that's definitely there. A y value of 0 definitely shows up. Would you guys agree? Shows up twice. Okay, right here, there is a y value of 1 that has a hole. Is there another place where there's a y value of 1, or is that y value missing completely? Y value of 1, is there another place where it's there, or is it missing completely? There's another spot, it's right over here. Okay, so we thought maybe that y value was missing, but it turns out it's not. Okay, so I looked at the spots that were weird in the graph, but it turns out there was nothing missing. I had to look a little bit further. I had to be a little bit careful there, but it turns out nothing's missing. So I have everything going down, everything going up. In the middle, it was weird, but nothing's missing. So how do I write that for the range? Negative infinity to positive infinity. Nothing's missing, so that means I have everything. Okay? All right. Next, we got to draw our stick figure. Remember, stick figures and increasing, decreasing always have to do with x values, okay? So this arrow right here, what's the x value that this arrow would describe? What x value does a left arrow describe? Negative infinity, okay? And then the right arrow over here, what's a right arrow describe? Positive infinity. Okay, so if our stick figure starts walking, what is he doing? He is definitely decreasing. It's like he's going down a slide. So he's decreasing, 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 decreasing until he hits this point. So what is this x value right here? -4. Okay, so he decreases until he gets to -4. And then he hits the bottom of this, and then what does he start to do for just a little bit? He increases, and then he goes into the secret hole of nothingness. And where's the secret hole of nothingness located? -3. And then he flies away into the sun. And it's like those myths that you learn in Greek mythology, you know? There's like some woman that seduces him, and then he burns up into the clouds, and then he disappears. We don't know what happens. Okay, so that stick figure is gone. We have a new stick figure that starts right here. What x value does the new stick figure start at? So this dot right here is -3, so the new stick figure starts at -3. Okay, what is the new stick figure doing? Decreasing. Okay, and does the decreasing ever switch to something else? No, it just slides straight down. Okay, so I wrote the word decreasing twice. Do you guys see that? So that means that for decreasing, I have 2 answers that I need to write. Okay, so this word decreasing is between 2 numbers. What 2 numbers is the word decreasing written between? Negative infinity and -4, okay. And then the other word decreasing is written between what 2 numbers? Perfect. I made sure I only use parentheses, and I put a U in between. I wrote the word increasing only 1 time, and the word increasing is just for a very little bit, and I wrote it in between 2 numbers. What 2 numbers did I write the word increasing in between? -4 and -3. Okay. How does your brain feel about increasing and decreasing on this type of graph? Do you see how I thought about it? Maybe we should do one on the practice assignment too. Yeah, okay. Max and min, we are looking for mountaintops and valleys. Do we see any mountaintops? No mountaintops. Okay. Do we? You will not get marked down if you forget the U. Okay. Do we see any valleys? Yes. What's the valley? -4, 0. We're going to write it like a point. -4, 0. So we got a valley. We never use an arrow as a minimum because it's not a valley. It's just a line going down. And infinity is not a point. Nope. Points have to be locations. So this infinity is actually written at -8, +5. Or +5, -8. No. Infinity. So if you ever ask a mathematician to talk to you about infinity, they would say it's a concept, it's an idea, it's not an actual number. I had a math professor once say that you had to be high to discuss infinity. That was a math professor, that's what he said. There was no other way you could discuss it. That's what he said. And if you think about it, it makes sense a little bit, is that if you try in your right mind to discuss it in a factual way, you're just going to get confused and feel like you're talking in circles. Because it's very hard, it's an abstract idea, so it's very hard to talk about and not get confused. So if you are not in your right mind, you might understand it. That was his point. Yes, exactly. Yeah. All right, intercepts. X-intercept, Y-intercept. Do you see an x-intercept? Do you see a y-intercept? Yes. What's the x-intercept? -4 and -3. What's the y-intercept? 0, -3. Okay. All right. Is the graph continuous? Can I trace the whole thing with my finger without picking up my finger? No. We are going to say no a lot today for continuous. There's a jump right here. It was about the time that our stick figure man was being seduced and dying in the clouds. No, he didn't jump off a cliff. He went into a hole. All right. End behavior as we look at the left arrow, as we look at the right arrow. No, Icarus had to do with wings and glue melting, right? No, Icarus wasn't seduced, was he? Oh, probably. All Greek mythology has to do with seduction. It's all messed up. It's all messed up. All right. What is the left arrow doing? Left arrow is going up. What's the right arrow doing? Down. All right. Ms. Rice, this is the 4th time we've done characteristics. Is it the last time? No. You guys. Thinking it's the last time. Silly. Yeah. Left arrow goes up. Right arrow goes down. Left arrow. Right arrow. Huh? Over what? When it says negative infinity, you're saying on the left, the very left end of the graph. Yeah, you're saying as you get close to x is -1 million, what's happening? So that's why you don't care anything about the middle. You only care about the very left edge. So whatever you can see is the leftmost side, that's what you're looking at. Yeah, good question. Yeah. Say it again. Yep. Yep. I do not think so. I am serious. We have a quiz on Monday. What else would we do before a quiz? All right. Let's look at this problem. Ooh, this has an interesting one for end behavior. Look at this one. Look at the end behavior. What is interesting about the end behavior? No, there is an arrow, but what's interesting about the arrow? Look at the left arrow. What's interesting about it? It doesn't go up. It doesn't go down. It's constant. It stays at a number. What number does it stay at? -1. Okay, so when we look at this one, the right arrow is easy, right? The right arrow, does it go up or down? Up, easy peasy. Right arrow goes up. Okay, that's comfortable, that's normal. The left arrow does not go up, does not go down. The left arrow is staying at -1. Would you agree with that? Left arrow goes to -1. Strange. Very strange. Very strange. Not hard, but we haven't seen one like that before. Yeah. Okay, so when you guys do your evaluating, you can do it by hand. You can practice plugging the piecewise functions into a calculator and do it that way. It is up to you. Okay. So if you wanna just figure out which piece you can plug them into, you can do it that way. If you want to practice being able to plug these into your calculator and use the table to know what the answer is, you can do it that way as well. There are benefits either way. Okay? Yes. You would get the table answer, multiply it by 5, get the table answer, multiply it by 3. I think he's probably mostly at Germ Tech. Yeah. His brother's here, though. Yeah, Pete. They look a lot alike, but their personalities are very different. Yeah. I do not believe that for a second. Middle school, maybe. How do we type in one like the second part? Your calculator doesn't like trying to type these in this way. The sandwich thing, your calculator does not like that. You use the and. X is greater than -3 and x is less than 1. X greater than -3, and then you hit second test, and then you go over to logic, and that's where your words are. And. It kind of goes along, remember when we were learning the absolute value inequalities, and I said less than would bring you the sandwich problems? And you can't type it this way, your calculator doesn't like it. Yours is more advanced. The rest of us, our calculators won't do it. Yeah. Yeah, no, your calculator. Because, so as they've updated the calculators more and more, they've made them where students don't have to know as much to plug things in. So it's like, you know how I said don't get a TI-83? You have to know a lot to be able to plug stuff into a TI-83. You have to know less to plug them in here. You have to know even less to plug them in there because they're... Yes. Do you have a typo? Oh, you have, is your window big?
No, my window's...
You don't have, oh, it's, okay, you don't have an X there.
Why not?
You don't have greater than or less than signs.
I thought you had to use the and.
You do have to use the and, but, so for here when you're programming it, you don't have your parenthesis, so that's probably messing something up. You don't have X is less than -3, you just have divided by -3. So some of your plugging things in is wrong. See that? So we haven't typed it the same way.
Wait, why do you do the parentheses and then the greater than sign?
It's part of the like computer programming aspect of it. It's just like the
Yeah, this is to do with math. This is just programming.
no, it really is. But if you go back and look at there you go. It liked it better. If you go back and watch the rest of that video, your calculator is easier to do it with. Your calculator has a setting, a piecewise function setting,
Okay.
where it will just have little squares and you can fill in the little squares exactly the way they should look.
Okay, thank you.
Yeah.
So do you just with this 5, do you just multiply the
Yeah, get the answer off the table and multiply it by 5.